Hey there, my fellow data enthusiasts. Welcome back to Quick Bites of AI, where we transform perplexing AI topics into beautifully digestible morsels. Today, we're going on a stroll through a lush, computational woodland known as Random Forest. And no, don't worry, there are no actual trees to climb here. Unless you're talking about decision trees, then yes, plenty of those. So let's start with the basics. I'm sure you remember our friend, the decision tree. It's generally like a tree that asks you a series of questions, helping to predict answers based on various conditions. Well, imagine a whole bunch of these decision trees living happily together in a random forest. It's called random, not just because it's a bit quirky, but because of the randomness and how it builds these trees. Now, why bother with many trees instead of just one big one, you ask? Good question. Ever heard the saying, 2 heads are better than one? Well, how about hundreds of trees are more insightful than one? A random forest takes the concept of wisdom of the crowds and gives it an AI twist. This is an example of ensemble learning, where multiple models, our trees, are trained to solve the same problem, and their outcomes are combined for more reliable predictions. Let's sprinkle in some technical seasoning here. Random Forest uses a process called bagging, or bootstrap aggregating. Basically, it creates a bunch of random samples from our dataset and fits decision trees to each sample. Then, for classification, it lets all the trees vote on the most popular output. For regression, it averages the results. It's like conducting a survey to decide which pizza topping is supreme pineapple or extra cheese. And, the result's always extra cheese, trust me. One remarkable thing about Random Forest is its ability to handle both classification and regression tasks with ease. And it's especially adept at dealing with missing data and maintaining accuracy even when parts of the data are missing or wrong. It's a pretty forgiving algorithm, unlike some of our friends after the last online game loss. But wait, there's more! Random Forest also introduces randomness in feature selection for each tree, meaning each tree is built considering only a random subset of features. This randomness leads to a diverse set of trees, which increases the robustness of predictions and helps tackle issues like overfitting better than a single decision tree would. Of course, like any hero, there are limitations. Random forests can be computationally expensive and memory hungry, especially when you have lots of trees. Also, while it's great for high-dimensional data, it's like your friend who's always late because they're overwhelmed by too much choice. A little bit slow. And now for the highlight reel. Where do we use Random Forest in real life? Well, it's all over the place, from banking for detecting fraud, to medicine for diagnosing diseases, to e-commerce for recommendation systems. You know, those super accurate items you may also like, suggestions that somehow know you better than you know yourself. And there we are, a journey through the Random Forest that, I hope, has been both enlightening and entertaining. Thanks for wandering with me through this thicket of machine learning marvel. Whether you're keen on coding up your own forest, or simply curious about how magically data becomes decisions, keep exploring and enjoy the ride. That's all for today on Quick Bites of AI. Stay tuned for more adventures in the world of algorithms, and remember, keep crunching those numbers and embracing the random paths life offers you. Take care, and catch you next time.